Today is the very first class of the physical pharmaceutics practical. So we will start with a very simple experiment. The name of the experiment is determination of angle of repose. On the board you are seeing some diagrams. Actually, to save time, I have actually pre-drawn it. But before we go to the topic, let's go to some of our observations. Whenever you notice the workings of the construction site, you will see stone chips, sand, cement, etc. lying in a heap. These materials are left in the nature unrestricted, and they take this shape, the shape of the hill. And you can look at this. There is a base and this is the tip, and between the tip and the base, if you measure, you can find some angle. This is the angle we are going to measure. This is the angle which is the angle of repose. So, two things I want you to note. One is the materials should flow on their own, not in a sack. The cement kept in the sack will have the shape of the sack. But if you allow the cement to flow freely through a stem, it will take this shape. If you allow the sand to flow through it, it will take this shape. Any fine material, if you allow them to flow freely, they don't make the flat surfaces. They give slants. They make angles. They look like cones. They are tiny hills. And this is the characteristics of the particles. And from these characteristics, we can find number of things, like how they are actually going to flow when you will be performing your real work in the laboratory, or when you will be manufacturing your medications in your factory. So this gives us very, very important information. All the hills, they have two characteristics property. One is the tip, another is the base. This base is in the form of a circle, and you know, circle is characterized by its radius, and this tip, this is the highest point of the heap joined to the center of the circle. So this is your height, and this whole thing is your diameter, and we are going to measure this height and half of this diameter first and get the ratio of it. Now you see, this is the smallest heap. Naturally, the base is also not very big, and this is the height. This is slightly bigger, this is even bigger. Suppose here we had only 1 kg of material, here 2 kg, maybe 5 kg. Accordingly, the spread was more and spread is least. The height is more here, sorry, and this is height is the least. But when you take the ratio of this radius, that is half of this diameter, and this height, in a way, height by base, all the cases will get the more or less same value, because the angle they make, that is same. Here we have demonstrated the actual experiment that will be shown to you, that will be performed by sir, and you will see it later. So you see, this is a funnel. Within the funnel some material is there, and from the stem of the funnel the materials are coming, they are falling slowly, and they are actually falling on a surface. And as they fall, they are spreading, and already the shape has started. When the whole of the material will come and hit this hip, will get a structure like that. Now, why this hip formation has taken place? When the first few particles have fallen, they have hit the ground directly. There was only ground. Over that, they have spread it, and there was nothing to stop their falling. But the particles which are coming later from the stem, they are actually not hitting the ground directly. They are hitting the already formed heap. And after already hitting them, they are trying to spread, but these already fallen particles and the falling particles, there is an interaction. You know that force, that is frictional force. So due to this frictional force, the flow is obstructed. So particles which are coming later and later, they will be having more obstruction, and they won't be able to spread and form a flat surface. So they will be stopped midway, and that gives you the shape. So you don't get a flat bed, you get a slanting surface. By definition, angle of repose, that is the angles that we are going to measure, is the steepest angle formed between the base and this surface and this base, the steepest angle. Somewhere you may be finding a little fault, some difference. In some cases, you will be finding a little flatter things, but by definition, it should be the steepest angle formed between the base and this slanting surface of, once again I note, of unrestricted materials. The materials must flow on their own. So you see, what we got is a slanting surface. Initially, the particles, they made a bed. They could flatly hit the ground, flow easily. There was nothing to restrict their flow. But the particles which are coming later through the stem, they did not have the advantage of hitting the ground. They will fall over the already fallen particles. So now the particles which are already there and the particles which are flowing according to their inertia of motion, there will be an interaction. Because of this interaction, they won't be allowed to flow freely. The force of friction will come into play, and because of this friction, they will be stopped midway. And as they get abstracted, they will be confined within the lesser area, and this way, more the material, greater will be the height, and we will be getting a slanting surface. By definition, the angle of repose, that is this angle, that will be formed. So by definition, the angle of repose is the steepest angle that's formed between the base and the slanting surface. We said we are going to measure this angle, but how do we measure this angle? For that, we have to refresh your basic trigonometry. So this is a triangle. The midpoint of the base, it has divided, and this is the perpendicular, it has divided the triangle into two parts. This is 90 degree, this is a theta, and we are going to measure the theta. So similarity of this, you see, here also we have got a circular base, and if you take a vertical cross section, you will be getting particularly this shape. This one is your diameter, the whole thing. The center, take the central point, this will make the base of a rectangular triangle. This will be the height, that is the line joining the T to the center of the angle. So exactly we are getting a rectangular triangle where hypotenuse and the base is making an angle theta. We are going to measure this theta by using the simple rules of trigonometry. What we'll do? We'll take the height, measure the height and divide it by the length of the base, which is the radius of that circular base, and the ratio height by base will give you the value of tan theta. And if you take the inverse of this value, you will get the angle theta. In the actual experiment, we will fill a funnel with a fine material, some particles. As the material passes through the stem of the funnel, will hit the ground and this heap will be formed. After the entire material has flowed through the funnel, we will measure this. But how will we measure? We will take a marker and make an outline around this, and the funnel will be removed. There will be, this height has to be measured. So this will be done by a scale. In your actual demonstration, you will see how sir will do it. So this height will be taken, this diameter will be taken, the diameter will be divided by 2 to get the radius, and then h by that radius will give you the value of tan theta, and inverse of that value will give us the angle. Sir is performing the experiment. For convenience, we have divided the experiment in number of steps. The step 1, you have to get the experiment ready. You have a stand, a funnel, some materials, marker and scale. Very simple things, and you see some papers are actually kept on the table. On this paper, he will be drawing a outline of the base. Step 2, he is filling the funnel. The material is being filled. Please take care there is no air bubble in it. If there are bubbles in it, there will be small bridges. You won't get uniform flow. So this is one point you have to note. And look at his finger. He has kept the stem above his finger. It's actually sealing the stem. The funnel is filled fully. So if you want to compare the flow properties of two materials, you have to take equal volume, because the conditions should be same, only one factor should differ. So in our case, we will be using the same funnel and we will be using different materials. So the conditions are same, and the funnels will be filled to the same level, so that the heap, if the flow is same, should ideally be equal, but it won't be. It won't be because the materials are same, or not same, sorry. Okay. Filling is complete. He has taken his finger, it's coming slowly, it's forming a heap. You can see it's forming a heap. Smoothly it has come out. Actually, we had taken granules. Granules have got circular shape. The friction between the granules is very less. Now the heap formation is there. Now he has to measure. He is making an outline, circular outline, not 1-2 points. Actually the objective is to get the diameter, but if it's not a perfect circle, you won't get the same diameter. That's why multiple points are taken. We have got a value of 2.1 centimeter. Now we have to go to the radius. So first he will remove the particles from the paper. He is doing it. Number of points had been noted, and that will is giving the outline of the circle. Draw the circle. Not a perfect one, but more or less a circle. No, almost a perfect one. Now we have to go to the radius. So how do you do it? If we take only one data, there may be plus minus errors. So he will measure the radius from different places. Straight line. Diameter should always pass through the center of the circle. If you take at different points, then you won't be getting that value. Another one. If you make more lines, more diameters, it will be more accurate, but minimum you have to take 3 measurements to be statistically valid. So note down the length of the diameter drawn. Note and write here. First one. Take the second one. For comparison purpose, we are performing this experiment with another material. Here we have taken sand, the sand you see every day, and you will see how it's flowing under the similar conditions. We did not change anything, the same stand, same height, same funnel, same extent of filling, but the material is different. So the purpose of performing this second experiment is just comparison, how the change of material changes the angle of repose. We are taking the same material but a different funnel. You can see this funnel is bigger than the other one, the one we had taken more first. So it will be loading greater amount of the higher amount of the material, and as the material is more in weight, we are expecting a bigger pile. So you see, compared to the earlier one, this one looks big, but when we calculate the ratio of the height and weight, we are expecting the same value as we got in the first time. The height has increased. Initially it was 2.1, now the height has gone up, it's 2.4. The experiment is over, but I am back to the board because it looks very simple, but most of the times when you actually do the experiment, you will see that values are not really accurate. So before doing this experiment, you have to remember certain points. You see, this is the tip of the funnel and this is the distance. This is the ground. When particles are coming from this point to this point, there is some open space between them. When particles fall, actually start towards the base, drawn by the gravity, there should not be any interference. But air is everywhere. If you have strong airflow, the fine particles will keep floating in the air. Number one. Second, if you take the funnel even higher, then this distance will increase and the later particles will hit the former particles, the fallen particles, with much greater impact. That may change the angle. So what I want to say is that the distance between the tip and the ground should be as less as possible. Now how do you know what should be the distance? First, make a rough experiment, make it fall, you know this is the expected distance, and fix your funnel at that place. That is one way. Or you can do one more thing. You can see that more the quantity, more is the time, more is the unpredictables. So you can fix a circle area and allow it to come up to that area. That is another way. The guideline is keep your funnel as close as possible to the ground. Now you may ask me, why should we measure this angle? Actually, this is important in pharmacy. It gives you very valuable information. In pharmacy, you know, the most popular dosage form is tablet, and tablet is actually volume filled. From the hopper, the granules come to the dye by flowing, and if the flow is interrupted, you don't get uniform tablets. In the mixing also, you have to take lumps of materials and mix them thoroughly. So if they do not flow freely, if there is too much of friction, the mixing becomes difficult. So drug excipients, we have to know whether they flow freely, whether they will mix freely, and we need to know their flowability or flow property. If the flow property is bad, we cannot use them as such. We have to modify them in a way so that they can mix thoroughly. And here comes the utility of the angle of repose. Angle of repose, the value of the angle of repose indicates whether the particle will be free flowing or not. A free flowing particle will give smaller angles, somewhere around 20-25, lesser the better. If a particle has high friction, it won't flow evenly, and that will give us bigger angles. So what happens? These particles are taken, their angle of repose is measured, the database is available, and just by looking at the angle, we know whether this particle is going to create problem during the actual processing. Now, I hope you understand the importance of this experiment. Thank you.
So, after the experiment, already you got that idea what is the experiment, what is the procedure, and what is the method, and already you have seen that how it have done in practically. So, the next step is the observation part. So, what we have observed during that experiment. So, we will put that data in table, then we will calculate. So, here you have seen that there is some table which is first column is which sample we have used, Here I think we have used in sand and some granules, and the number of observation, how many times we have done the same things, and then that next column is the height of the heap. Okay, so this is in centimeter. The radius base of the heap, we will got generally diameter. So during the measurement of the diameter, you should careful about that maximum distance between that circle should be, because we know that diameter is the maximum distance. Okay, so we should calculate the radius of the diameter. We should divide it by 2, and next column is the ratio of the h by r, means height by radius. And next, if you observe so many experiment, then we will go for the average HR. And as in the beginning, when the introduction have given of that experiment, so we know that angle of repose means the tan theta is equal to h by r. Theta is the angle of repose. So if we know that tan theta is equal to h by r, so theta will be tan inverse h by r. So here we have written that angle of repose is equal, theta is equal to tan inverse h by r. So ultimately, when we got that value of the theta, then we can say what is the flowability characteristic, whether it is free flowing, whether it is not free flowing, whether it is slightly flowing. So there are so many classification of the flowability. That flowability also we can calculate of a different type of experiment, like different type of index. So that experiment will be done later. So just see the table. So we will give you the data during our classes. So you just calculate and fill fill the table. So then you can compare the data and what is the flowability like that. So okay, thank you very much.